Okay, we're going to work problem 45 in section 3.4. That's on page 326. Notice the instructions say find the relative extrema, if any, of the function. Use the second derivative test, if applicable. And the function is f of x equals sine x plus cosine x, and we're looking in the open interval from 0 to pi halves. So, here we go. F of x equals sine x plus cosine x, and we've got to remind ourselves that we're between 0 and pi halves. Now, relative extrema have to do with critical values or critical points. That's where the derivative is 0 or undefined. The derivative is cosine x minus sine x. Won't ever be undefined, but it could be 0 at some points. So let's ask, hey, where could that be equal to 0? Well, it would be equal to 0 where cosine x, if we add sine x to both sides, equals sine x. So what values, if you plotted sine x from 0 to pi halves and cosine x from 0 to pi halves, where would it be that they would output the same value? Well, that would actually be exactly halfway in between, because these graphs are sort of mirror images of each other. So that would be at pi fourths. Remember that pi fourths of cosine of pi fourths is root 2 over 2, and sine of pi fourths is root 2 over 2. So the critical value, or critical point, is x equals pi fourths. Now, if we were going to do an interval, we have this one critical value on our interval. We might do it, and that's where the first derivative is equal to 0. We might do the derivative to the left and right, but that would be the first derivative test. It's asking us to run the second derivative test, which says, okay, let's figure out what the second derivative of this function is at pi fourths. So I'll take the second derivative. The derivative of that, of course, is negative sine x. The derivative of that is negative cosine x. What happens if I take that value at pi fourths? Remember this, sine of pi fourths is root 2 over 2. Cosine of pi fourths is root 2 over 2. If I have two of them, that's negative root 2. The important thing is that's negative. Well, if you have something that at this given point has slope 0 but is concave down, that means there is a relative min at x equal pi fourths.